Number 4 reads, a 3-watt night light is plugged into a 120-volt circuit and operates continuously for 1 year. Find the following. A, the current it draws in amps. B, the resistance of its filament in ohms. C, the energy consumed in a year in kilowatt hours. And then finally, D, the cost to run your night light if the utility rate is 11 cents per kilowatt hour. Okay? So this is a perfect 4-step problem. On number 4, step 1, we make a little sketch. This one's pretty simple. We got a little night light that we plug in, yay, and then obviously once you plug it in, it gives off light. It's as simple as that. Nothing fancy. Okay, we just want to keep good habits. Step 2, we list all of our known and unknown information. We're given that it's 3 watts, 120 volts, 1 year. Okay, 3 watts is a measure of power. 120 volts obviously is a measure of voltage. And then 1 year, what's 1 year a measure of? Time, that's correct, okay? Later on we're going to have to convert years, it's kind of a pain, into hours for kilowatt hours, okay? So, not horrible, it's just something we got to do, okay? Next, the knowns and unknowns. Part A, we want to find the current it draws. Current is a measure of amps. So now, we're going to do just the first part. We're going to do step 3. Oh. Okay, now that my computer's done crashing, must be Monday, right? That's okay. We're going to find our current was our first unknown. I in amps, okay? So in our toolbox, we want to use our power equations. There's 3 versions of the power equation. We'll just use a basic one. Watts is equal to amps times volts. So this is just basic plug and chug, okay? So in this case, this one's pretty easy. If the power is 3 watts for my little tiny light bulb, I can find the amps if I multiply, by the volts, okay? So the current's just going to be simply 3 divided by 120 because a night light doesn't really draw a lot of current. It's just a little tiny bit of current to keep this thing running. So 3 over 120 is simply going to be 0.025 amps. So that's part A. We got our first answer there. Next, part B. We want to find, let me scroll down here, the resistance of the filament. Resistance is measured in ohms, okay? So we want to find resistance in part B. So there's a whole bunch of ways we can do resistance. Probably the easiest way is to use Ohm's law. Remember the Ohm's law triangle? Put V on top, I on the left, R on the right. So if I want to know R, I just cover up R, right? So R is equal to what? Everybody, V divided by what? V over I, right? Piece of cake. So now we can just plug in. For voltage, we put in 120. For amps, we just solve for, it's 0.025. We'll plug that into our calculator. We'll do 120 divided by the voltage divided by the current. V over I gives us my resistance of 4,800 ohms, okay? And you're like, wow, that's a lot of resistance. Well, that's because we don't need a lot of current flowing, just a little tiny trickle current to light up our filament there. Okay? Next, part C. Let's keep this moving here. Yay. In part C, scroll back down to the problem. There we go. We want to find the energy consumed in kilowatt hours and then the cost. So we need energy and cost. So we need energy is our next unknown in kilowatt hours, and then the final thing is cost. Show me the money. That's all people care about in the end, right? In dollars and cents. Okay, well to get kilowatt hours, that's pretty easy, right? We just have to change watts to kilowatts. So 3 watts is how many kilowatts? You just divide by what? Kilo means 1,000, right? So 3 over 1,000, we just move the decimal place over 1, 2, 3, right? 0.003 kilowatts, right? Next, hours. This is kind of annoying. We need to change 1 year into hours, okay? So the easiest way to convert is a factor label method, where you put like terms on top and bottom to cancel out. So we'll get rid of years, and we'll first go to days, okay? And in 1 year, there's how many days typically? 365, right? 365 and a quarter if you want to be technical. like for leap years and all that. We won't worry about that, okay? So notice, then we can cancel out like terms. The years cancel out. Next, we need to get rid of days. So this isn't too bad, because we can now finally go to what? Hours, right? And in one day, how many hours? There is 24, right? Sometimes it feels like there's too many, or not enough, depending on how your life is going. And now we have our final units. Yay! So this isn't too bad, right? We just do 365. Everything on top you multiply, everything on the bottom you divide. But you don't only have to do the ones, right? So just 365 by 24 gives us 8,760 hours. Okay? So we don't want years. We want hours. So we get our energy consumption. Energy is simply equal to power times time in kilowatt hours. What do you want to use for power? Do you want to use 3 watts or 0.003 kilowatts? Which one's the right one? We want to use what? 0.003 kilowatts, right? And then we multiply not by 1 year, but by 8,760 hours to get our kilowatt hours, okay? So if I take 0.003, I can multiply that by 8,760, and I get my kilowatt hours. 26.28 kilowatt hours. Yay. Okay, so that's part C. We got 26.28 kilowatt hours. So finally, show me the money. We can get our final answer. To get our final cost, we just need to know the rate, the utility rate. And the utility rate was given as, here it is, 11 cents a kilowatt hour. That's actually pretty expensive. You guys are paying a lot less now, okay? But rates will only go up as energy becomes more scarce and expensive. So eventually we got to figure it out, okay? So costs, we can finally finish. Show me the money. Cost is just simply equal to the rate you're being charged times the energy that you use, right? So in this case, we got 11 cents a kilowatt hour times 26.28 kilowatt hours. This will give us our final cost in cents, and then we can just change that to dollars, right? So 26.28 times 11 cents is 289.08 cents. Yay. Anybody know what the power company will round that up to? They'll round that up to what? $2.90 is what you'll have to shell out, okay? So to run a nightlight all year, leaving it on 24/7, it doesn't cost very much at all, because nightlight's only like 3 watts, right? But little things add up. So again, for now you don't really care, you don't pay your bill, but one day when you're the old man like me and you got to write the check every month, every penny counts, okay? And it's all about energy efficiency and finding alternative forms for the future. In a nutshell, number 4, yay.